OK, that's how firewalls are operated. So if you're the network operator, you're the one specifying all those rules and maintaining those rules as users complain or you find new attacks. Now, the thing we haven't talked about is how the firewall implements your rules. So now let's talk about that. So as mentioned earlier, you can think of a firewall as basically a packet filter. It looks at every packet that is traveling across the network and decides either to allow the packet and forward it, or deny the packet and drop it so that it doesn't reach its destination. So the firewall just needs some sort of code that checks each packet and decides allow or deny. It's a piece of code that returns true or false for whether you allow the packet. So the simplest firewalls you can build are stateless packet filters. And here, the word stateless means that the packet filter looks at every single packet independently without thinking about any other context. So the stateless packet filter doesn't have to remember anything that happened in the past. It doesn't have to keep track of any special state. It just looks at every packet one by one without considering any others and decides yes or no. So this is nice because it's pretty simple. You just look at every packet individually, and you don't have to keep track of anything complicated across all these different packets. You can just make the decision based on what's in the packet itself. But the trade-off is that even though it's simple, it will have some trouble with implementing more complex policies. So if you want something that's really complicated, the stateless packet filter might not be able to achieve what you're looking for. So here's an example of how you might use a packet filter to implement a policy. So let's go back to that old policy that we talked about, the sample one where we said anything outbound is allowed. Anything inbound is allowed if it's in response to something that was outbound. And anything that's inbound that's not in response to an earlier request is denied. Could you implement this with a stateless packet filter? At first, it might seem difficult because there's this rule that says I have to allow traffic that's in response to something earlier. So it seems like I can't just look at one packet and decide whether or not it was in response to a previous connection. That would require remembering earlier packets and keeping track of state. But there are some hacks that might make it possible. It's not going to be perfect, but you could try and statelessly filter packets according to this policy. So to do that, you will take advantage of the fact that TCP has all those different flags. And usually, when there's a packet that's being sent in response, the ACK flag is set. Because not only are they sending you data, but they're acknowledging what you sent to them. So when a packet comes back and the stateless packet filter sees that incoming packet, it can check if the ACK flag is set. If the ACK flag is set, it means that the packet is saying, here's some data, and by the way, I received something from you earlier, so here's an ACK to confirm that I received it. That would imply that the packet that's incoming probably was in response to something from earlier, since it's acknowledging something earlier. However, if you get an inbound packet without the ACK flag set, then that might be a sign that the packet is the first one in the connection. For example, if you think about that three-way handshake, the first packet is the SYN packet. The ACK flag is not set there because you're not acknowledging anything. You're just sending your initial sequence number. So that could be a sign that inbound traffic is not in response to something from earlier. So you might deny a packet if the ACK flag is not set. So that's a little hack you can do. It's not perfect, but it could be used to try and filter TCP connections just by looking at the packet itself without looking at anything before or after. Now, with UDP, it's harder or maybe even impossible to do because UDP packets don't have an ACK flag. It's just some packet that you send. And it's pretty much impossible to figure out if that packet is being sent in response to something or if it's the first packet in the connection. So with UDP, trying to filter statelessly is pretty hard, if not outright impossible. But that's an example of how you can statelessly filter packets.